Hey guys, I'm in a meeting today looking at some sample TCAP questions, so that should be fun. But anyway, I expect you to continue on with part two of your notes, and I'm just going to go over them very briefly and make you watch this before I let you go on and actually do the Nearpod on your own. Okay, this is the harder part, I think, of the electrostatics part, okay? All right, so remember that we're talking about static electricity, which is all about those electrons. And static electricity just means when those electrons build up on an object. We don't really know a better way to phrase it than that. So when those charges build up as static electricity, it will get to a point where the material or the object just can't stand it anymore. Like, too many, too much. And it's just like, I got to get rid of some of these things. And so it's going to get rid of some of them in kind of one big zap known as an electric discharge. And that's what lightning is. But when we are forming static electricity, we've got three main ways that you can get that buildup of charges to happen. Okay. All right. So here's the first way. If you start out with two objects and they're neutral, and I'm going to say because the kids that come on Thursday and Friday saw this last week, and I'll do it at some point. You guys will probably see it in a little video clip we've got in the next lesson. But if I take a plastic pipe, which is called PVC pipe, and it's neutral, and then I take a piece of wool, which is also neutral. If I take that cloth and I actually rub it, touch it directly and have that rubbing motion of friction, then this really cool thing happens. Turns out that some of the electrons from the piece of wool will actually just transfer. They'll completely move over to and pile up on that PVC pipe. And it's kind of cool when that happens. Now, I want you to think about it. That means that the piece of wool, if it's giving up its electrons, that means it has given away negatively charged electrons, and it becomes just temporarily, just for a little bit, it becomes positively charged. Meanwhile, the PVC pipe has gained electrons and it would become negatively charged. So we end up with one object that's positively charged and one that's negatively charged. So that's pretty cool. So what does that look like? Well, we've given you some directions. I'll show you right here. They are. We've given you some directions, and we want you to simulate this idea of building up static electricity through friction. So you'll be using this simulation again, but for this part of the Nearpod, we just want you to notice that here's the balloon, and notice you've got the same number. You've got an equal number of positive and negative charges on the balloon, so it's neutral. The sweater is neutral, and this wall over here is neutral. Now, we'll come back to this wall a little bit later, but this wall is neutral. Now, neutral, neutral. But if I take the balloon and I touch it and I rub, so this is the friction. Now look what has happened here. Now the electrons went from the sweater, transferred to the balloon. The balloon now has an overall, look, it's got way more negative charges. So it's become negatively charged. And our sweater gave up the electrons and it became positively charged. And now positive and negative attract. And there you go. Okay. And so I think we've given you a little something to do with that as well. All right, but that's not the only way you can get static electricity to build up. Okay, so the first one is by friction. Now that's, remember, contact, and you've got to have that rubbing motion. Well, there's another way that you can get static electricity build up. And this doesn't involve the friction motion. But look at this. It's a little bit different. It's not too tricky. We'll show you. If you have a neutral object and you bring something that's already charged close to it, it's already charged. Now, we'll say it's negatively charged. If I bring some object that's got a bunch of extra negative electrons and I bring it over and just touch it, okay, I don't rub it, but I just touch it, it turns out that some of the electrons will move from here to here, and now they would both end up with a negative charge. Okay, remember, protons don't move. The only thing that can move is the negative charges. So the negative charges would move over and they would both end up with that negative charge. So here's an example of what happens with conduction. And you may have seen this before. This is called a Van de Graaff generator, and you'll see it in the video. The Van de Graaff generator is going to build up a charge. This young lady is going to start out neutral, but then she's just going to touch the Van de Graaff generator. Now, she's not going to rub it. She's just going to touch it, and that's conduction. And you're going to see that she is also going to develop a charge. And what happens here on her hair is her hair actually all becomes charged. And since the charge on her hair is the same, they're going to repel each other, and that causes her hair to move apart from each other. So we'll let you watch that on your own. And then here's just kind of a Van de Graaff generator. You know, they work in different ways depending on which one you're looking at. But I think if you guys will just overall get the idea that it is just a buildup of excess charges. And what happens when the young lady touches her hand is that some of the electrons leave her body. They get attracted and come over here to this positive charge. They leave her body. She then herself becomes temporarily positively charged, and you see that her hair spreads out from each other, repelling each other. All right, so here's the last way that you might get some static electricity to build up. And I'll show you what this one looks like too. So you notice we start out kind of the same way. You got a neutral object and a charged object, but there's a difference. You bring the charged object close to the neutral object, but you don't touch it. You don't touch it. And what happens is, and I'll show you this in a minute, the charges kind of rearrange themselves, and we call that inducing a charge in the neutral object. So let me show you what we want you to do. And again, we've given you some directions, but I'm going to show it to you here. So we're back to that same simulation, and you notice there's this wall hanging out over here, right? Okay, so I'm going to start out the same way. I'm going to take my neutral balloon. I'm going to go over here and use friction. All right, there we go. I used friction because I had that rubbing motion and I actually touched it. And you notice my balloon has a negative charge, right? So it's got a negative charge. The wall over there has a neutral charge. It's got an equal number of positive charges and negative charges. But watch what happens. Now, I'm not going to touch it. I'm just going to bring the balloon close. Oh, do you see that? Look at that. All right. So what I'm doing, this is called inducing a charge in the wall. And I'm not touching it, but basically what's happening is the negative electrons in the wall are being repelled. They're being repelled by that all those negative electrons in the balloon. And when that happens, right there on the wall, you can see closest to the balloon, it induces a positive charge in the balloon. And now, there we go, the balloon will actually stick to the wall right there. So this is called, again, I can induce the charge right here without actually touching. Once the charge is induced, then I can go ahead and take advantage of that charge and the balloon will stick. So then we talked to you just a little bit about conductors and insulators. And this is important, all right, because when we are talking about static electricity, some materials, which are conductors, will let electrons move pretty freely in them. And so metals like copper and gold and silver will do that. But you have other materials that eh, don't let electrons move very much, and those are our insulators. Now, think about it, guys. You probably know that styrofoam is an insulator. Maybe you've used a styrofoam cup or a styrofoam cooler, and you do that because if you have a styrofoam cooler, you might put some ice and cold drinks in there, and you want them to stay cold. Well, it turns out that we have certain things that are because they don't let the electrons move through them, instead, the electrons pile up on them. Styrofoam is a good example of that. I told you my plastic PVC pipe is a good example of that. So, that static electricity can, again, form pretty easily right here when you have that insulator. The electrons don't like to move through it, so instead they pile up on it. So we have a little video here. This guy, this little TV series, oh, it's old, 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 but we just like the demonstrations in it. I think this guy is called Mr. Wizard, way before Bill Nye the Science Guy. So yes, it's kind of corny, but watch it anyway because he does some really good demonstrations in there. Well, here's the thing. I want you to think about that. If you have static electricity building up, and we have it building up and then creating a big static discharge, such as lightning, then that can be dangerous. Like, that's not good. And so, actually, buildings, you might notice, some really tall buildings have a little piece of metal right here on the top. It's a lightning rod. And that metal runs all the way down the side of the building and into the ground. And the whole point of that is to attract that lightning, attract that discharge, let it follow. Remember, metal likes electrons. It'll let electrons move freely and basically just dump it into the ground. The ground is neutral and it's like big, really big. So it's like we don't care. Give us a few extra electrons because like it's not going to bother us. So this idea of grounding is a good way to get rid of that really big static discharge. Okay. All right. So I think that's it for this particular thing. We gave you same thing as you were doing last week. Here is a guided note sheet. Remember, it will make a copy for you. Do not try to type in this little thing. Click right here. Always click the blue words, and that will make a nice big copy for you. And you can use the Nearpod and go back through. You can mess around with that balloon and that sweater if you want. Once you get your notes taken, then you are ready to work on this. So this is going to take you to that same simulation again that we just used, but we've got some questions for you. And then we have another simulation you will like. And this is called John Travoltage. Let me go ahead and pull it up because it's just pretty funny. Here he is. He is on the carpet. He's on the carpet. And you notice here is a metal doorknob. And oh, I'm going to get some electrons from that carpet. See? Oh, look at that. Those electrons, and they're going to go. There's that metal. Metal lets electrons move through it pretty easily. We've got a couple of questions for you there. And there you go. And we'll let you mess around with Mr. John Travolta. All right. So I will double check, but I think that is what I want you to get done on Monday. So let me double check again for you. So that hopefully everything will be working right. So again, you will do the, we have a starter for you, and that's not up here yet, but I want you to do your starter. Then you'll use the Nearpod to complete it and take your notes. And then you also have another activity with the balloons and John Travolta and static electricity. There's a very short claim evidence reasoning in here, and that is what I expect you to get done for today. All right.